Hey everyone, today's topic is rational numbers on the number line. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward too much that you miss out on something important. Let's get started. So to start us off, let's talk about what a rational number is. A rational number is any number that's positive or negative, so it doesn't just include positive numbers. It includes all positive and negative numbers that can be represented by a ratio of two numbers. So that actually covers a lot of numbers because a lot of numbers can be turned into ratios, even whole numbers. So for example, 0, -3, -4/5, 8.125, or in other words, 8 and 125 thousandths, -293.01, or 1/100ths, 9 and 1/2. Those are all examples of rational numbers. They are including positives and negatives, and they can be represented by a ratio of two numbers. So even 9 can be represented by a ratio of two numbers because 9/1 is a ratio. Or even 18 halves, that still becomes 9. And even if it has all these really, really small decimals, they still can become ratios because this is 1/100ths, 1 out of 100. This is 125 thousandths, so it still can become a ratio. So it includes 0 itself, because 0 can become a ratio as well. 0 out of 1, 0 out of 2 still becomes 0. Positives, negatives, whole numbers, fractions, and decimals. Those are all what we call rational numbers. And you'll learn more about rational numbers in 8th grade when you start talking about irrational numbers, but you don't have to worry about that yet. So far, all the numbers that we've covered in math class are together in a group called rational numbers. So today we are talking about how we can plot rational numbers on the number line, all those different types of numbers. Let's start off with whole numbers. And make sure you have that definition in your notebook before you move on, because we're going to talk about how to plot 3 different types of numbers. So with whole numbers, remember that 0 is the border between the positives and negatives, and the numbers are written like they're reflected on a mirror. So the positives are going in normal order 1, 2, 3, 4, and then the negatives look like they're going in reverse. But basically the number right next to 0 is still 1. The number 2 spots away from 0 is still the 2, except it's negative. So the negatives are going in reverse order. That's very important when you're trying to find or plot your whole numbers. Next, with fractions, they're a lot like your tape diagrams. So just like with your tape diagrams, you need to figure out what your denominator is, and that's going to help you figure out how many lines to draw. So you're going to draw one less line to divide that whole into parts. So for example, to divide the whole into eighths, you would only draw 7 lines. And what's most important with the fractions, if you were ever asked to plot fractions, is you always want to include the neighboring whole numbers, the numbers on the other sides. So make sure this is in your notes as well. Here are some examples of what we're talking about when we're saying plotting fractions. So they look a lot like your tape diagrams. So this is 0 halves, 1/2, and 2 halves, which is the same as 1. All of these are like ones. They are the entire whole. The part out of the whole is matching. So just like a tape diagram, if you're splitting into 2 parts, you're just going to draw 1 line. If you're splitting into 3 parts, you're going to draw 5 lines, 1, 2, 3, 4, 5, because your last line is basically your last part to that whole. So a lot like your tape diagrams. make sure you've jotted down at least one example of what we're talking about in your notebook. All right, and then the last thing we want to cover in our notes is how to draw decimals or plotting decimals on the number line. So decimals are very similar to your fractions, except we know that decimals go in tenths, hundredths, and thousandths, and they are multiples of 10. So for drawing tenths, you are going to draw 9 lines in between to mark off each tenth. So there are 9 marks between the whole numbers. And the scale would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And then we have the 1. If your decimal is in the hundredths, for example, let's change this to 1.16. Then you, or 0.16, if it were 0.16 or 16 hundredths, then you would find that it is between 0.1, which is right here, and a little bit past it, between 0.1 and 0.2. So you would put your dot right here for 0.16 or 16 hundredths. Okay, so drawing the 9 lines to show your tenths is a great starting point so that you can then find where specifically your dot is when you are plotting those decimals. And you're going to find it at the best approximate location. Your 0.16 would be around right here. You wouldn't put it super close to 0.1 because it's actually a little bit more than halfway between 0.1 and 0.2. And again, you're always going to include your neighboring whole numbers. If you are dealing with decimals that are going by the scale of 0.2, then you can do a little bit of a shortcut and you can just count by those 2 tenths. So you would only draw 4 marks if you are just plotting numbers that are going by 2s. So that you would have 0.2, 0.4, 0.6, and 0.8. Similarly, if you are going to go by what we call like the quarter numbers, like 25 cents, 50 cents, and 75 cents, then you would only draw 3 lines because there's 4 quarters in a dollar, so you have 1 less. So that's if your problem is just dealing with those types of numbers. Normally you would be drawing 9 tick marks because these obviously show more specific locations. The more lines you draw, the more specific it gets. And then if you're just going by halves, then you just need to draw 1 line in between to show that half. Just like for the 0.16, there is a half in between here, the 0.15, so that's how we knew that the 0.16 is just a little bit over. Okay, so those are the different ways that you can draw your decimals, plot your decimals on the number line. Make sure that you go back and have this in your notes before we move on to examples. Okay, for this example, we are given a number line. It looks a little different from the number line we looked at before because normally it goes left to right and this one's going up and down like a thermometer, but it follows the same rules. You need to drag the following cards to match each point to its value. So A should be matched up to its correct value, B and C. Go ahead and pause the video and try it on your own first. Okay, you should have seen that you have a 0 here. And that 0 is very important because it's going to divide up our positives on top and our negatives on the bottom. So let's take a look. I see also 1 and 2, -1 and -2. So our positives are on top, negatives on the bottom. And in addition to that, I see only 1 line being drawn between the whole number. So between 1 and 2, there's 1 line. Between 1 and 0, there's 1 line. 0 and -1, there's 1 line. So if we remember from our lesson, we know that if there's 1 line, that means that there's a 0.5 in between. So that's going to help us out a little. Okay, so for A, I see it's between 1 and 2, so it's the line between 1 and 2. So it should be 1.5, 1.5. It's halfway between 1 and 5, so it's 1.5. So this one should be 1.5, 1.5. For B, it is between the 0 and the -1. So it should be negative 0.5. It should be halfway. And for C, it is right on -1. Okay, so I see that A is 1.5, B should be -0.5, and C is -1. However, I do see this 3 halves here. That's throwing me off a little. So I will need to change that to something that I recognize. There's a couple ways you can do this. You can change this into 3 divided by 2. So 2 goes into 3 one time, and that will give us a remainder of, that will give us a remainder when we subtract it of 1, and then we bring down the 0, so then 2 goes into 10 5 times, so that it divides evenly. So that changes into 1.5. You could also change it into 1.5 by changing it from an improper fraction into a whole number. This is 3 halves. 3 halves, here's 1 half, here's 2 halves, and here's 3 halves. So this shows us it's 1.5, or 1.5. Okay, different ways that you can show that 3 halves is the same as 1.5. So it looks like we're going to move some of this stuff around. So we have A was at 1.5, so that's going to be the 3 halves. B was at -0.5, and C was at -1. So it should match up. Okay, so sometimes they'll add in some fractions and decimals. Remember, those are both rational numbers, so they can change them. They are equivalent, just written a little differently. For this example, we have a number line with A, B, and C points. We need to find a reasonable value for point B. So it needs to make sense where you put the value, all right? Go ahead and pause the video and try it on your own first. All right, you should have, again, zeroed in on that 0. It's going to separate your positives from your negatives. So automatically, if we're trying to figure out what B is equal to, we're going to get rid of all positive answers. So C can't make sense because 0.1 is on this side. And then we are going to remember that our positives and negatives are going in reverse order. So these smaller numbers are going to go to the right-hand side. Okay, so over here is going to be smaller than -1.5, and over here it's going to be bigger numbers than -1.5. Not bigger values though, just the numbers themselves have to be bigger. So let's see, A could work because it's bigger than -1.5. B could work because it's bigger than -1.5. The 9 is bigger than the 5. D cannot work because -1.3 would be here. Remember, the numbers are going in reverse. It's going 2 and then 1, just like how here it's going 5 and then 3. So we're down to either A or B. Well, A is a much bigger number. -4 is much bigger than -1.5. So I can eliminate that because -4 should be like all the way over here. It's too big. Remember, it has to be reasonable. It has to make sense that it's over there. This is a little closer, so I would go with -1.9. I would go with this one right here. Because on this scale, you're going to have a bunch of different lines. So this is going to be -1.6, -1.7, -1.8, and then -1.9. Just like how here's -1.4, 0.3, 0.2, 0.1, and then to the 1. So these are going by tenths. So negative 1.9 works here because it's going little by little by little by little to get to that negative 1.9. Negative 4 is too far away for that. So it should have gotten B. Okay, let me know if you have any questions as you work on these problems at home, and I will see you in class.